Yeah.
Ah, well there. No.
Oh, what's wrong with you?
That will change, don't worry.
Don't. No. What are you doing?
Be good, please.
Be good.
Thank you. Alright. Let's go on. Okay.
No.
Wow.
This is not enough.
This one.
This is much better.
This one.
No.
Okay, now be good. Right, we're having a look at maths now. So, we're looking at something called the product rule. Siobhan, do you mind? Thank you.
Wait.
Sit down. Come on, guys, you're late. No. You need to get an earlier bus if that happens. Right. So, in semester 1, we had problems like this, where we had y equals x squared, and we knew how to differentiate that. That was 2x. And we had something like y equals sine x, and we knew how to differentiate that. What's that? Cos x. So it seems like if we have something like x squared sine x, we should know how to differentiate that. But in fact, right now, we don't. We can only differentiate x squared and sine x, but we haven't learned how to differentiate something like x squared multiply sine x. Now you might be thinking, what's there to learn? Isn't the answer just going to be something obvious like 2x cos x? And this is a no. It's actually not this. Life would be too easy if it was this. So there must be there is a special way to do this, to differentiate this. I just want to show you why it's not this obvious way. So, for example, let's take something that we do know the answer to. If I say y equals x squared, the derivative here is 2x. We've done this one so many times. This is definitely true. Now, I could change x squared into x times x. And if I tried to use my imagined rule, I would get dy dx equals derivative of x, which is 1, derivative of x, which is 1, which is 1, which is obviously false, because we were trying to get 2x as the answer. So, clearly, when we multiply, it's actually more complicated than what we think it could be, or differentiating. So now, let's try and find out how to do that. Okay, can I scroll down? Yeah. So, do you remember first principles? First what now? First principles? Who remembers that?
Blanket x plus h.
That's the one. Yeah. Yeah. What's that? Leave me alone.
I'm using this pen when you need it.
Okay. Sigh. Right. So let's say we have y equals some function f multiplied by some function g, like this. And we want to know what is the derivative. Well, from first principles, that's f x plus h, and of course the g gets an x plus h, minus fx what am I doing? There. Minus fx gx all over h. This is the first principles definition. You have x plus h, x all over h.
What does h stand for?
A small number. Wow, you did really forget this, yeah?
I wasn't there. It was the time I was sick. I decided to never watch the video because I realised there was an easier way to
Good,
do it.
good call, good call. No, because in the exam, sometimes the question will say, by using first principles, differentiate. You're correct, of course, there's a much easier way to differentiate, but sometimes in the exam they want you for simple functions like quadratics to use first principles. Best watch the video. Be a wise thing to do.
I remember hearing people moan and
Yes.
cry and
Yes, and you probably would have heard a couple of people say, but can't I do this another way? Were you one of those people? Yeah. Right, so this formula is not really helpful, we need to simplify it. So here's the trick to simplifying it. It's still all over h, of course. And here I have, of course, still fx plus h, gx plus h. And at the very back I have minus fx, gx. But I'm going to put something in the middle. Oh, no. No. Dude, wait.
Yeah, no, I sent you an email.
Is it a good reason you're late?
You read the email.
Okay, in future, I need to, now you see, you know there's a problem developing at 9 o'clock, whereas people are having trouble being in at 9 o'clock. So in future now, I think people coming in this late will have to wait until the second class. Starting from tomorrow.
Not tomorrow, not yet tomorrow.
Correct. Oh no, you still get marked absent, which you can enter. But from tomorrow, you get marked absent and are denied entry. Yes, but today,
So I did send you an email before 9.
that's fine, but did it have a good reason in it, or was it like, hey teach, sorry I'll be late, just grab me a cappuccino?
No, it wasn't like this.
Alright.
Don't do it at all.
Oh, a latte.
No, the email was like.
Alright. Now, the way to simplify this, we have to add a piece and subtract a piece in the middle. So what I'm going to do is subtract fx gx plus h and add fx gx plus h. Now, why is this still the same? Well, because the middle two pieces cancel, yeah. So I haven't really changed it. However, when you look at the first two terms, there's now something in common I can take out. What's in common that I can take out here?
GX plus H.
Gx plus h, yeah. So you can be left with fx plus h minus fx. And let me take out gx plus h. Plus, and what about in the back two, what's in common? Fx, isn't it? Yeah. Fx bracket gx plus h minus gx. Now this is all over h, but I'll put the two halves over h. So I'll put this half over h, and I'll put this half over h. Just separate like this. There's a good reason for me to do this as well. Because now if you look at this, what happens when h becomes 0? Well, I think this piece is obvious. What does this become when h becomes 0? Well, that will become just gx, obviously. And this bit here is not affected. It will become fx. But what about this piece here? What will that become when h goes to 0? No, everybody gets this wrong. Everybody, every year gets this wrong. Not 0. Not this. Not 0, not 1, not undefined, not infinity.
Cancels out.
Not cancels out. fx, no. No. No.
It becomes fx minus fx over 0.
Which is not 0 over 0, no.
Derivative.
Becomes derivative of f.
Yeah.
Because this is the first principles definition of the derivative of f. So this becomes the derivative of f. And what does this become? So we have our formula. What? Classic Stephen. Right. Classic maths, yes. if y equals f times g, then the derivative of y will equal derivative of f times g plus f times g derivative. This is called the product rule, which is the name of the lesson.
Do we need to know everything before the formula?
What does your heart tell you?
No.
No.
Correct. But what will your teacher tell you?
It just says
Write
no.
it down.
Yes. Yes. All true.
But what about g x plus h can't be g x?
Huh? This becomes derivative of g.
No, I mean g.
Here
Yeah.
becomes gx.
Why?
Because h is 0. Yeah, at the very end here, you make h go to 0. Got that, guys? Yeah. Let's have a look at some examples now. Ron, do you have this? Okay, hurry up.
Second semester.
Yes. What about it?
Can I get
Possibly. But certainly not today. I'm too busy today. Maybe even too busy this week.
After 2 weeks from now, after we get our
This would be the best time. Yeah.
just the button Control P.
You cannot imagine how busy I am. Even
I
this
can
is
click
too
it
much.
for you.
It's not just Control P. I have to enter my printer code. I have to pick double-sided. I have to pick staple. It's more than just Control P. There's at least 5 other buttons I have to press.
Why you not let someone help you?
Oh, I need an assistant, do I? Personal assistant.
I
Like
can do it all
Roland,
for
you
free.
can give.
Make me coffee,
All
print a
for
book.
free.
Alright, let's have a look at some examples. I'll see what I can do. Does anyone else want it? No. I'll see what I can do. See, and that's the other thing, it's not just going to be printing for you now. Right, let's have a look at an example. So let's check that this rule works with our example of x squared. So y equals x times x. Let's test that this rule works. So according to the rule, you differentiate the first term, which is 1, and keep the second term the same, plus you keep the first term the same and differentiate the second. That's x plus x, that's 2x, as expected. So clearly the rule works. So let's try it on something now that's new. Let's try it on something like,
A square.
what?
A square thing.
Yes, the original problem we had, x squared sine x. So according to the rule, we differentiate the first term, which is 2x, keeping the second term the same, and then we keep the first term the same, and differentiate the second. And that's it.
No.
The only thing you can do is take out x, I guess. That's all you can do. Yeah?
But if in the exam we can use the proof.
Yes. Lee, you have a question? You don't look happy. Are you unhappy? Are you happy? Can I try another example?
Why did we not take out the x from the sign in the class?
Those are
Here and here?
No.
Oh, that's quite haram. No, sorry, actually, no, you need a different word. That is quite forbidden. Yes, we cannot do that. It's quite simple, quite simple. No, the x is tied into the sine and the cos. It can't be pulled out. It's part of the sine and the cos. It can only be taken out of the coefficients in the front then. Let's have a look at another example. Let's do something like, we'll do one with e in it. Let's just say x ex. Let's do this one together. So, firstly, what's the derivative of x?
1.
1. And ex stays the same. And then x stays the same. And derivative of ex?
X,
Ex just. Yes?
So,
You're thinking of something else? Yeah. I suppose I could take out ex. Okay, let me give you one to try by yourself. Now that I've done a few examples. So we'll have e minus x sine x. Give that a try. You have answers? Vaughn, do you have an answer? Wong? Yeah, okay. So what's the first part?
minus
Minus e minus x
sine
sine x. Plus?
E minus X cos.
If you want, you can take out e minus x.
minus
Minus
sine.
cos.
Yeah. Okay. So that's part, let's make this a multi-part question. So part A can be find the derivative. Part B, which I want you to do, and let me restrict the x for a moment. We'll just say x is between 0 and pi. We'll let it equal 0. Will we?
No.
No, we can let it equal 0. Do I want to let it equal to 0 is my question.
You really don't. Look at them.
Yeah, I don't think I do want to actually. No, let me think. I want to think. No, it does actually. Well, it doesn't. Kind of doesn't. I won't include 0 or pi. X is between 0 and pi. So the next part of the question which I want you to do is I want you to find the exact turn-in point. And I'll emphasize this word, I don't want a decimal answer. No calculator, exact answer.
What you want to find with? 45 is pi over 4.
You will not get full marks for this answer. Read the question carefully. the answer. Turning point. So many people needlessly lose a mark for this mistake. Okay, let's have a look here. This one's a bit tricky. How do we find the turning point? The derivative equals to 0. But this looks like a pretty tricky equation. How can we solve this? Well, it's actually not as bad as it looks at first. Because this is equal to 0, it means you have two possibilities. Either e to the minus x equals 0, or cos x minus sin x equals 0. But this we reject, because e to the power of x is never 0. So the answer must come from this part. So that means we have cos x equals sin x. 1 equals sin x over cos x. Who remembers what sine over cos is? Tan x. So then x equals tan inverse 1, which is pi over 4. You can put that back in to get the y. So then y equals e to the minus x over sine x. So that means y equals, this is root 2 over 2, e to the minus pi over 4. So this is the point here. Well. Now, why are you so late? Really? For half an hour?
No, I came and...
Yeah, so you're still late, right?
I came in with that during the day.
And I don't think they were exactly on time either, so you're late either way. Now, from tomorrow, if you're this late, I'm not letting you in.
Why, if the first one is reject,
Yeah, why do I reject the first one?
put ln.
Yeah,
Log-
put that
log-
ln. So you get minus x equals log 0.
Yeah.
So type in log 0. No, never type it in.
I thought it's 0.
It is not 0. It's not anything. Okay. I'll give you a, yeah?
Minus pi over 4. E last.
E power minus pi over 4. Okay, can I scroll down a bit? What?
What is that?
What's what?
Find
This?
find the
This?
expansion point.
Find the y, if you know the x. Yeah? Here, I put the x in here to get the y.
Oh, so it's just not the point.
For the, yeah. Last part here for this one, I want you to check, is it a max or is it a min? How do you do that?
The second derivative.
Correct. Check. And remember, this is the first derivative.
Is it more preferred to solve it as a product rule or expand and then?
I would use a product rule at this without expanding.
Oh, because if we expand it, it's a product rule for both. Yeah, you're lost here. You're lost. You didn't do this before, so there's no lost the video.
Anybody get an answer yet? Think the max? Okay, let's calculate the second derivative. So that's going to become a minus e minus x, and this is still cos x minus sin x, plus e minus x, and this will become minus sin x,
Minus cos.
plus, minus cos x. If you put in pi over 4, do you know what, actually, I will take out the e minus x, and this will be minus cos x, plus sin x, minus sin x, minus cos x. So it's minus 2 e to the minus x cos x, and then if I put in the pi over 4, I get something that's definitely negative, which makes it a max.
Question.
Yes.
The second one.
Here?
No, above it.
Yes.
Yeah, the cos is minus or plus? No, down.
Here?
Yes.
That's a minus.
Okay, and then the next one.
That's a minus. That's a minus.
Because
That's a plus.
Yeah.
That's a minus.
Yeah.
Continue. Can I scroll down? Yeah. So look, here's the rule again. Y equals fg, and the derivative is f derivative g plus fg derivative. But what do you think is the rule if you have, say, 3 of them? F, g, h. Y derivative equals, what do you think?
Derivative f gh plus f derivative g h plus f g derivative h.
So what is happening is the derivative runs through the list, differentiating each one as it goes along. So you could do this for as many products as you like. Yeah. Okay, one last example, and then I'll let you try some from the worksheet. Can I scroll down a bit? Y equals sine squared x. Let's differentiate. So what's the trick here, do you think?
Sine squared.
No.
Change it into sine x. Sine x.
No.
Yes?
Yes.
Yeah? Yes. How else could you do it?
So it's cosine x squared.
It will be cos x sine x plus sine x cos x, which is 2 sine x. Yeah?
Sine square is equals sine square or not?
No.
Yeah, that's what I was thinking.
What about sine in bracket?
Yes, but brackets are important. Sine squared x equals sine x sine x. Sine x squared equals sine x x. Sine brackets x squared is the same thing. Sine x x.
What about
I'm getting it. Sine x squared is sine x sine x. The same thing as sine squared x. What is?
What about sine squared x?
Sine squared x squared is sine x x sine x x. Like that. Squared? Everything's squared, but not the x's. So it would be sine x x sine x x sine x x sine x x. Yes. It's all the possibilities, really. Okay. Can I scroll down? Yeah? Right. So, listen. In semester 2, some people might say it's a mistake, but in semester 2, I treat you more like adults. I know, some people might say that's a mistake, but it's got to be more your responsibility to manage your own studies and revision in semester 2, because if you think about it, not only do you have new material to do in semester 2, you will also have to revise yourself material from semester 1, because the final exam has everything on it. And not only will you have new material, you will also have coursework and labs and other things like this. You'll have EAP presentations or whatever. So you will be busy in semester 2, and I feel it's not fair for me to give you homework that I expect done a certain amount at a certain time, because you need to have the flexibility to manage your own work. So for example, maybe you do more maths one day and less the next day. So, you know, in semester 1 I was giving you homework each class, so the homework was kind of a constant thing. But in semester 2 you might find that it's a bit more like this, because some days will be busier than other days. For example, this is your first week, so you probably have no labs, right? No coursework yet? Where?
Labs and
Chemistry lab.
Tomorrow, yeah. And will Lorraine need you, or whoever it is, need you?
to submit the draft tomorrow.
Exactly. So maybe it'll be easier for you to do the homework for today and tomorrow. Do you get what I'm saying? So I'm not going to be telling you what to do and how many to do. You need to judge for yourself.
Can you suggest some questions?
No.
Questions on the worksheets are good questions.
They are.
I suggest those.
Yes, and also if you mix and don't just pick all from question 1. But you know this. You're not stupid. Everyone here is quite not stupid. So, I want you to have a look at the worksheet and pick out some questions. You can do some of them now and maybe mark some you feel would be good to practice at home. Okay? But you need to take more responsibility in semester 2, because it's just going to be really busy semester. There's a lot of things to do. Okay? So if you take out your phone and have a look at Moodle, the first lesson is the product rule. If you can do that for 10 minutes. Yep? What? What? You don't have a phone? You do, it's charging up. Where is it?
Behind your laptop.
Don't trust him. What's wrong? Yeah, do some Moodle questions, please. No, sorry.